Let's jump directly into direct proportion. Now, direct proportion means the ratio of two quantities is always the same. So in other words, the ratio x over y equals k for some constant k. Now, if the k part is confusing you, don't stress too much about that, because as we do some examples, you're going to see that it's more important to just focus on keeping the ratio x over y the same. Now, before jumping into our first problem, I just want to make a little note. Notice that in direct proportion, increasing one quantity means the other must increase as well. For example, let's say you were given the ratio 2 over 3. But let's say that 2 increases to a 4. Well, if the 2 increases to a 4, then the 3 must increase to a 6 to keep the ratios balanced. And once again, if the top increases to a 6, then the bottom has to increase to a 9 to balance everything out. Now you might be looking at this and saying to yourself, direct proportion is just ratios. And that is true. That is exactly what it is. So it's a fancy name, but as we can see, it's nothing too difficult. Now let's get into the first problem, which says that if x and y are directly proportional and x equals 3 when y equals 7, then what is y when x equals 10? Okay, so I'm going to show you how to set this up. If x and y are directly proportional, that means, by definition, the ratio x over y is constant. Now you can also say that the ratio y over x is constant. That is true. It doesn't really matter which one you pick, as long as you are consistent and you're matching your letters correctly. So we're given that x equals 3 when y equals 7. And we're asked to find y when x equals 10. So if x equals 10, this is a 10, and we're trying to find the corresponding y. So all we need to do now is solve for y, because we know 3 over 7 equals 10 over y. So from here, we can say that 3y equals 70, which means that y equals 70 over 3. And that's all there is to it. So you can see that direct proportion is just setting ratios equal to each other and then solving. So that was the first example of direct proportion. Let's take a look at another example that's slightly trickier because you just need to read the problem a little more carefully. On to the next example, which says that if x and y squared are directly proportional, and x equals 2 when y equals 9, what is x when y equals 7? So a little bit different, because this time it's not x and y which are directly proportional, it's x and y squared. Which means the ratio x over y squared is constant this time. So not x over y. Which means our ratio is not 2 over 9 this time. Instead, it's going to be 2 over 9 squared, which is 81. So that's the first given information. Now we need to find x when y equals 7. From here, it's just become solving for x. So 81x equals 98, which means that x equals 98 over 81. So that was just a brief introduction to direct proportion. Now, let's see some very common problems which use direct proportion to solve them.